Everyone, so we're back. It's now towards the end of the day, and we are going to, you can't see what's on my screen here, and we are going to go over two more examples, and these are called compound inequalities. So in the video that you should have watched last week, I talked really briefly about on a number line when your answers can point towards each other, and that's called between, or they can point away from each other. And that's kind of what we're seeing here. So what I want to do is talk about these two situations, all right? So solve the following inequalities, and we're going to graph your solution set on a number line. So because I have two inequalities, I am going to have two answers. And the way you're going to have to look at this is with two problems. So I would recommend for the beginning, you look at this as two problems. So there's one problem. So negative 4 is less than 3x minus 1. And then the other problem I need for you to focus on is that 3x minus 1 is also less than or equal to 8. And you're just going to have to solve the two problems. You'll have the same steps as you solve them, but you're going to see different results because of what 3x minus 1 is being compared to. So either way, we are solving for x. So I'm going to draw a line. And what I'm going to do is get x alone. So it's a simple two-step equation because I don't see any parentheses. I can't combine the like terms, and the x is already on one side. So I just have to work backwards in the order of operations, the two steps. And the first thing I'm going to move is my addition subtraction. So when they subtract one, I'll add one. And again, whatever I do to the one side, I do to the other side. So as we like to say, those cancel out. If you have negative 4 and you add 1, you get negative 3. And now I'm going to divide. So I'm dividing because to undo that multiplication, I'll use division, and I'll divide. So there is a negative number involved, but I'm not dividing by a negative number. I'm dividing by a positive number. So my inequality sign is not going to be switching directions. So just a heads up. So negative 3 divided by 3 is negative 1. These cancel out, and we are just left with x. So remember, this is one of those times where we want x on the left side, and it's on the right side. So I'm just going to rewrite it real quick. I'm going to say that x is on the right side. We'll put the negative 1 on the left. Sorry, x is on the left side, negative 1 is on the right side. And since I'm switching everything, I'm going to switch this direction as well. So if you remember the alligator, what it eats. So if you think about it, this is eating the x, or it's pointing to the negative 1, and that's still happening here. The alligator is eating the x, or it's pointing at negative 1. So now I'm going to solve the other one. Same steps, just different results. So I'm going to move my addition subtraction, so I'm still going to move the minus 1. And, excuse me, I get 9. These cancel out, and we get 3x. And now to undo my multiplication, I'm going to divide. And I get the 3. So, and I like this answer because x is on the left side. So now since I have two x inequalities, I'll put them both on here. So again, I like to put my reference point at 0. I'll have to deal with negative 1 and 3. And again, when I graph, I like to graph with x being on the left side. So I'll use this one and this one, not this one. So this is saying that all of my answers are going to be bigger than negative 1. And remember, since it's pointing to the right, I can do that. So this one I'm going to put on the number line, so it's going to be an open circle because it's just greater than, and it's going to go to the right. So, all right, and then when I do this one, this is saying that all my answers are also going to be smaller than or equal to negative 3. So I'll put a closed circle because of the equal to part, and then it's going to point to the left. And if you notice, everything is just in between those two numbers, all right? So if you think about it, remember how I showed you the way this was written? I could actually take this, and you'll see that it will actually work the same way. So I'm going to show you up here. I'm going to put the x in the middle. The smaller numbers on the left, the bigger numbers on the right. And if you look, do you see how this is pointing at the negative 1? I'm going to have it point at the negative 1. And on this one, how it's pointing at the x, I'll have it point at the X. And when your symbols, excuse me, look like this, an X with two less than signs, again, it can also be less than or equal to, which I did forget on the 3. That means between. All of the answers are between -1 and 3, but they can also include 3 because of that underlining part. So let's take a look at it here. So again, I'm going to have two problems. I'm going to have 3 minus 2x with the -1. And then I'm going to have 3 minus 2x with the 11. All right, oh, and it's underlined over here. So again, I look for my prep work. We're really not seeing much prep work in these inequality problems. So parentheses, no. Combine like terms on each side, no. And move x to one side, it already is on one side. So again, I'm just going to use my order of operations to get my backwards order of operations to get x alone to isolate x. So I'm going to move 3 by subtracting it. You don't add it. If you add 3, because some people see the subtraction and think they should add 3, you have 3 plus 3 and you haven't gotten rid of it, you've just made it bigger. So make sure you're using the correct operation. So -1, take away 3 more, well that's a -4. And now I'll undo this multiplication that's happening here. I'll use division. So I'm going to divide by -2. And again, this time I am dividing by a negative number. So I'm going to go ahead and put my 2 here, my x here, and since I divided by the negative, I do have to switch that direction of the inequality sign. And again, I don't like my answer with x on the right. Now I'm going to rewrite it so x is on the left. So x, 2, and then I'll switch this as well. So it's still pointing at x here, it's still pointing at x here. So I'm going to use this one in just a moment. And I'm going to use the same steps to solve for this one, but just as I go through, I'll get different numbers. So I'm still going to subtract 3, still subtracting 3. So I get -2x. There's less than or equal to because those canceled out. Here I get 8. And now I'm going to divide by -2, and I'm going to divide by -2. Those cancel out. There's x on the left. 8 divided by 2 is -4. And again, we just divided by a negative number. So that inequality sign will have to switch. All right, so I'm going to put these two on my number line. So again, I like my reference point 0. Here's -4, and here's 2. So I'll just start with the 2. So this is saying all the answers should be less than or equal to 2. So less than, smaller than 2. I'll make a closed circle, and it's going to go this way. And then when I do the -4, this is saying all my answers are greater than or equal to -4. And again, it's pointing to the right. Use that little trick. It is a closed circle still. And now it's going to go to the right. And eventually they meet. And again, I can take this and write it like this one. It's okay to leave them separate, but when it shows up between, like it does here, it is truly better to write it as one big inequality sign. So just to show you why that works, here's x in the middle, the smaller numbers on the left, the bigger numbers on the right, and let's just start with the 2. So do you see how the inequality is pointing at the x? Still going to point at the x. And in this one, it's pointing at the -4. I'm still going to make it point at the -4, and they're both underlined. So this is truly the best way to write it than the two separate ways. All right, so where does the answer go on the number line? How do you decide? The number goes on the number line. You know, you want to try again just to put your 0, kind of your placeholder, and try to space things. You don't need to make a bunch of little tick marks and evenly space things, all right? And then just remember, when you divide by negative, you got to flip that sign around. So that's it. So your homework is going to be, or your practice, I should say, is going to be on page 17. And then you're also going to be looking at page 18. So the answers will be posted on Schoology, and this will also be mentioned on Schoology. I just want to talk about a little bit real quick before we jump out of this video, how you set these word problems up. So I'm going to kind of maybe get you set up on 7 and try to get you set up on 9. So these are very similar problems to what were in the the practice that we already did. But you got the velocity, and it's modeled by this equation. So this is velocity, 3t plus 18. And v is the velocity, and t is the time in seconds. So, and again, time is always non-negative, so you can't have -3. So we're going to find when the velocity is less than 54 meters. So let me just show you another way to approach this. I'm going to take this sentence and write it as an equality, right? The velocity, v, is less than 54 meters per second. I'm going to leave the meters per second out. So you know how when we did the section, given x find y, given y find x, we would substitute numbers in? Well, this time we're going to substitute 3t plus 18 in for v because it is v. So I'm just going to rewrite it. And now I'm going to solve. And remember, your answer is non-negative, so you got to make sure that you keep it between your solution and 0 because it's not going to get any smaller than 0. All right? On 9, just maybe getting this set up a little bit together. So 3 times a number increased by 8 is no more than the number decreased by 4. So this is a bit of a challenge. So let's start with this. 3 times a number and then increased by 8 is no more, and then here's the other side of the inequality side, than the number decreased by 4. So 3 times a number, so 3 times some number, and then that's increased by 8. We're going to put an inequality sign here, is no more than that same number decreased by 4. So the challenge is, how is that inequality sign going to go? So it's no more. Let's think about what that means. No more meaning it can't be any bigger than this. So if anything, it can't be any bigger than this. It's got to be less than. So I guess if you think about it, you know, going back to that carnival ride, if you went up to the carnival and it said, you can't be any more than 4 feet to ride this ride, like 4 feet is the max, so you got to be less than that. So we're going to put a less than symbol. And sometimes it's very straightforward, like this less than, and sometimes when it's phrased, you know, in this fashion, you really got to think about it. And what I like to do is just put the carnival example with it, all right? And maybe that helps. And then you will have 10. That is multiple choice. So I will have very basic answers also posted on the Schoology page, but remember, no work, no credit. That's it. Thanks.